All right, so for this one, it says consider the absolute value function. F of x is equal to the absolute value of x plus 3. How can the function f be written as a piecewise function? Well, let's look at the absolute value function. Okay, so I'm going to graph this real quick. Let me make sure. Yeah, I got to clear all this stuff out. So to graph an absolute value function, I'm going to hit math and go over to number, plug in absolute values, and I'm just going to say x plus 3. Now, from your algebra days, algebra 1 days, we know that there's two solutions. In other words, this has to equal a positive or negative whatever. So the obvious answer on this is that you have the positive part of this expression, and then you take the negative of this expression. So let me explain what I mean. Let me zoom in here to a standard fit, and I'll take a screenshot of that. Put that in our notes. So this is the graph of the function, okay? So this is what it looks like. And I'll move this down here. That is the absolute value of x plus 3. But I just want to take the negative of that. So as you can see here, what the first part of this piecewise function is the positive part, right? So this is just as you see it in the absolute value brackets. Now the next part of this would just be the negative of that expression. In other words, what's the negative of x plus 3, right? Because when you put that in the absolute value brackets, you just ignore the negative. But I'm going to think of this as being a -1, distribute it through the parentheses, and I get negative x minus 3. And we'll verify this in a second. So it looks to me like down here we're going to plug in negative x. Whoops, not plus. Negative x minus 3. But now we have to set the boundaries, right? So the boundary is going to occur where? Well, let's look at it like this, okay? X plus 3 is the positive part of the function. In other words, it's this part right here, right? This part right here is x plus 3. Well, the boundary here is 3, right? X equals -3, right? Because that's where we're switching. That's where our piecewise functions come together. And the negative part of that expression is this part right here. Okay? So in my expressions, my domain restrictions are going to be at -3. That's when I'm going to flip from one to the other. Now, which one I include, it doesn't really matter, but I can include both. I mean, I could, but that's not a good practice. So I'm just going to say x is greater than or equal to this because we're on that expression, I'm really focusing on all of these x values, right? Let me put that in blue so you guys can see what I'm talking about. I'm really focusing on these x values. So my domain for this portion of the piecewise function are going for x is greater than or equal to -3. Now on the other side, it's all the values less than that, right? But I can't include 3 twice, so I'm just going to say x is less than -3. Now, if I want to double check that and see if that works, we can plug that into our graphing calculator. So I have this function here, right? And what I'm going to do, I had to I had to restart my calculator there. So what I'm going to do is I'm going to come in here, and now I'm going to graph this as a piecewise function. So I'm going to say x plus 3, right? And that restriction is going to be x is greater than or equal to negative 3, right? Whoops. I hit the wrong. There we go. X is greater than or equal to negative 3. And now for the next part, I'm going to put negative x minus 3. And my domain restriction on that is going to be x is less than negative 3. Okay. And so when we go to graph this, what should happen is you should see the red line first, and then you'll see the blue line. And they should be the same curve. Ready? Here we go. That's the absolute value function. And now my piecewise function. I'm going to come in and graph here. Uh-oh. Did I graph it right? Let me see where I made my mistake. I hit the wrong button. Do you guys see that? Plus. Good. Now it'll work. Like a glove. Okay. So it matched up. Perfect.